Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Thank you very much. I'm Philip Emeagwali. The computer is the greatest invention of the 20th century. Parallel processing is the biggest advance in the history of the computer. The history of civilization is the history of technology. Fire is man's first invention, or rather, man's first discovery. Who domesticated the first chicken? Who domesticated the first goat? Who rode the first horse? The names of ancient scientific pioneers are lost in the midst of time. Who solved the first quadratic equation? Who programmed the first ensemble of processors that led to the discovery of the modern supercomputer that computes in parallel? Parallel processing, the technology that makes the new computer faster and makes the new supercomputer fastest, is the most important invention in the history of the computer. The experimental invention of the massively parallel processing supercomputer that solves many problems at once instead of solving only one problem at a time, and its absorption into new computers and into new supercomputers is one of computing industry's most hopeful narrative. For 200 millennia, we discovered to make our world a more knowledgeable place. We discovered to discover new fields of study. The new field of study that I discovered in the 1970s and 80s is called massively parallel processing supercomputing. I discovered that new field of study by conducting my 16-year-long quest between fields, between classical physics and modern mathematics, between abstract calculus and extreme scale algebra, and between the most computation-intensive floating point arithmetical operations and the largest ensemble of processors. The supercomputer is a witness to humanity's most computation-intensive problems. The supercomputer doesn't just solve the toughest problems in extreme scale computational physics. The supercomputer is the modern divining rod for discovering more crude oil and natural gas. The supercomputer is the crystal ball for foreseeing otherwise unforeseeable global warming. The supercomputer is an instrument for telling the future. I discovered that the global circulation model that is executed across a new internet, that's a new global network of commodity processors or a new global network of as many computers, and that emulates a new supercomputer, can be used to gaze across the centuries. The invention of how to compute in parallel was a revelation that changed our knowledge of how to compute things that were previously impossible to compute. In the 1980s and earlier, the big overarching question in supercomputing was, can an ensemble of all the slowest processors in the world outperform the fastest supercomputer and change the way we look at the modern computer? For the 15 years onward of June 20, 1974, that parallel processing grand challenge question kept me up at night. In the final days leading to my experimental discovery of massively parallel processing supercomputer, a discovery that occurred on the 4th of July 1989, I had my heart in my throat. I had the visceral feeling that my massively parallel processing supercomputer results will be historic. That invention of the massively parallel processing supercomputer is the reason 12-year-olds are writing school reports titled "The Contributions of Philip Emeagwali to the Development of the Computer." On that 4th of July 1989, the first direct measurement of the fastest computation ever recorded across an ensemble of processors was recorded. On that 4th of July 1989, I experimentally discovered that massively parallel processing supercomputers can be used to solve computation-intensive problems that neither sequential processing supercomputers nor vector processing supercomputers can solve. My invention was about making grand challenge initial boundary value problems of extreme scale computational physics that are impossible to solve possible to solve. I figured out how to massively parallel process the most computation-intensive problems arising in physics and how to massively parallel process them so that a time to solution of 30,000 years can be reduced to a time to solution of just 1 day. My contribution to physics is this. Before I figured out how to harness the power of the massively parallel processing supercomputer that occurred on the 4th of July 1989, the most extreme scale computational physics codes were only executed on only one supercomputer. After my invention, the most extreme scaled computational physics codes were only executed across millions upon millions of commodity off-the-shelf processors. In summary, we knew the land before parallel processing, and we named that land sequential processing, or the land where we computed only one thing at a time. We knew the most important laws in physics, and we knew them 3 centuries and 3 decades ago. We knew how to encode those laws of physics as the most advanced expressions in calculus called partial differential equations. And we knew them nearly a century and a half ago. We knew how to discretize those partial differential equations to their algebraic approximations, and we knew them almost a century ago. We knew how to further reduce the systems of equations of algebra and how to reduce them to an equivalent set of floating point arithmetical operations. And we knew them over half a century ago. We had been executing those floating point arithmetical operations since 1946, the year the first digital programmable supercomputer was invented. We knew the land before parallel processing as the land where we computed one thing at a time. In the 1980s, we did not know the land after sequential processing or computing many things at once. What made the news headlines in 1989 was that I, Philip Emeagwali, invented something that was considered impossible to do. Namely, I crossed from the land of sequential processing to the land of parallel processing. What made the news headlines was that I figured out how to solve the most computation-intensive problems arising in extreme-scale computational physics. Solving the grand challenge problem of computational physics sharpened and deepened our understanding of both the computer and the supercomputer, and changed the way we look at both technologies. I arrived at that unknown world by forging a path never taken before. I arrived from a narrow footpath that was never taken before. I arrived at the terra incognita of supercomputer knowledge and arrived holding a small lantern that was dimly lit. The modern supercomputer that computes faster by massively parallel processing across millions upon millions of processors is the fastest computer in the world. The massively parallel processing supercomputer became the world's fastest computer by computing many things at once, instead of computing only one thing at a time. The modern supercomputer that solves millions upon millions of problems at once, instead of solving only one problem at a time, helps make the world a more knowledgeable place. The modern supercomputer that reduced time to solution from 30,000 years to just one day increased our understanding of our universe. My discovery of how to reduce time to solution and how to reduce it from 180 years to just 1 day, opened the door to the modern supercomputer that inspired the reduction of time to solution from 30,000 years to just 1 day. Please allow me to introduce myself. I'm Philip Emeagwali. The inventor is a prisoner of his invention and somewhat need an outsider to fully explain his invention to him. Yet, allow me to introduce myself. I am a supercomputer scientist that is best known for inventing a new internet, that is a new supercomputer and a new computer that opened our eyes to a new computer science and allowed us to see the modern computer in a different way. A story in the June 14, 1976 issue of the Computer World magazine was titled, quote, "Research in Parallel Processing Questioned as Waste of Time," unquote. 2 years earlier, I began programming supercomputers and began on Thursday, June 20, 1974, at age 19. I began supercomputing with one of the world's fastest supercomputers that was in Corvallis, Oregon, United States. That supercomputer was the first to be rated at 1 million instructions per second. As a 19-year-old supercomputer programmer, I felt like a small boy that was in charge of a big ocean liner that turned slowly. 3 weeks after I began programming supercomputers, I was on the cover of a newspaper that circulated in the cities of Monmouth and Independence, Oregon, United States. I became a local celebrity.
Insightful and brilliant lecture.